¿Qué tal? Muy buenas tardes a todos.
Good evening, everyone, and welcome to our last workshop for the day, on our third day here at CyberCamp 2018. I hope you're making the most of our workshops and the presentations and the activities that we've prepared for this program. Before I introduce you to Cristóbal Espinosa, I would like to remind you to use Twitter, and the hashtag is CyberCamp18. Cristóbal has a master's in information security, and he's a lecturer at the University King Juan Carlos. He's now working as a cloud and security manager at Accenture, where he works with projects to securitize cloud projects, and he's a specialist at Amazon Web Services. A warm round of applause for him. Cristóbal Espinosa. I hope the microphone's working okay. Everything is ready. Great. I'll be honest. When I told you your workshop will start at 6 o'clock, and I thought, oh dear, Malaga, good weather. Nobody is going to be there to listen to me. Well, I was wrong, fortunately. Thank you very much for coming. So, I've prepared a workshop with an introduction to the most common services that we can find on the Amazon cloud. I want to summarize the best practices and security recommendations given for each and every one of them. Here we have the table of contents, starting with a little bit of background about myself, about what I do, then an introduction for Amazon Web Services. How many of you have used AWS? Please raise your hands. And how many of you have gone in depth into it? So, you've got a superficial knowledge, as far as I can see, but no in-depth knowledge. So, what is AWS IAM, which is for user authentication? We'll see that first. Then what tools we have for data protection, which infrastructure services we have on WPC, machines, and all of that. Then the container services. I have very little time, so I'll just tell you about the databases, about DS. Then abstract services, mostly S3. And then finally, specific services for security that Amazon gives us. So, I'll tell you a little bit about myself and what I do, what I've been covering, and why I want to tell you about this particular topic. So, my name is Cristóbal. I'm an IT engineer. I then did my master's degree in Madrid on ICT. And then I've been working with auditing. So during my professional career, I've been working mostly with the cloud. In 2007, I was given an award for that. And then I also have the Microsoft Active Professional certificate. So this all started with development and management of different projects. I then started to go more in depth into security as a freelancer. I've also been working as a CISO, and I've been very much involved with Amazon. That's what I keep busy with. So I'm here to tell you about Amazon Web Services. AWS provides different services where we can work with computation in the cloud. So we have three different types of services. First, infrastructure as a service that contributes all basic elements that we need for the infrastructure. Then the platform as a service with different utilities and everything we need that's up and running for configuration and settings, but not very much in depth. And then the typical service, for instance, email, and different tools that we have in the cloud that we can use, but we have no access to configure and work with settings very much. So in Amazon, they work with a shared model. That's how they call it. So when we work with Amazon, there's part of security that Amazon looks after, and another part we have to cover. So what is cloud security? It's tasks that Amazon needs to comply with for the architecture underlying the services. For instance, machine security, the security of the virtualizing layer, everything that has to do with our data centers. Logically, that's not something we should be concerned with. And then we have the other side of the coin. That's what we need to cover. That would be security in the cloud. When I'm using Amazon services, then it's my responsibility to take into account everything I do is secure. For instance, configuration for my firewall or the software that I'm going to be using, and so on. So certifications and conformity, how does that work? In Amazon, there's a very large team of people, experts in security, who guarantee that all of that complies with laws and regulations and requirements. So when we have a project that we want to run on Amazon, then it needs to comply with a number of different certifications, and Amazon has a list for those. Globally speaking, that would include Cloud Security Alliance, different ISOs that have to do with the cloud environment, different certifications that are important in the US as well. For instance, I often work with banking or healthcare. IPAM is important there. Different restrictions, depending on the area in the world, those change. In the European Union, the new directive for privacy. So they comply with all of that. What does that mean? Their infrastructure is prepared to comply with those certifications. Does that mean that when I use Amazon services, I'm suddenly complying with everything? Not really. For instance, the S2 system, right? There's S2 system. If I want to have a website with patient information for healthcare, just because I'm working with that system, does that mean that I'm complying with HIPAA? It doesn't. For instance, a web portal where I can download information on patients, well, that's private information. If I was really useless and I did that wrong, then I might have to go to court. I might be sued. So we still need to make an effort to comply with those regulations, even if I'm using their services. What about trust and confidence when I work with cloud services? Sometimes people worry. It's like working with somebody else's computer. Instead of having a data center dealing with that, I now have it in the cloud, and Amazon deals with that, and I have to trust that Amazon is doing that correctly. In their design, when they set up a data center, they find a place which is safe from earthquakes, from floods, to guarantee availability and security. What about physical access? Well, there are very strict policies for third-party information access and also to avoid destruction of resources. For instance, Amazon has equipment like this. I don't know if you can imagine how large that is in the real world. For instance, an Amazon hard drive, when they're obsolete or when they're not working properly, well, they first need to safely erase the sectors 7 times or something like that. But even after that, this type of machine would end up like this when they destroy it, to make sure that all information is safely erased. So I think that's probably enough for background on Amazon. And now we're going to move to the IAM side of things. What is IAM? When we use an Amazon account, we can do it in different ways now, not in the past, because in the past we used to say, well, I have an Amazon account and then I can start the WPC, their networks. So I could have different access to different networks of theirs. I could have a sub-network for security elements, or even subdivide the networks for the different departments. Well, that was in the past. Now we don't need to have everything on a single account with different WPCs. We now have the possibility to have a master account and then other accounts for different development environments. We can also have accounts for security and different accounts for different departments. Why is this an advantage? Because we can separate things. In the past, it was separated through WPC, but at the end of the day, it was all part of the same account. So let me give you an example. In 2014, a company, CodeSpace, one day suddenly announced they were closing down. Why? Because somebody had accessed their system and had erased everything they had on Amazon. Somebody found the root user, the main user, or the only user, and erased everything. The machines, the hard drives, user details, backups, everything. What can you do in a situation like that? Nothing really. If your recovery capabilities were part of that account, in that situation where the root account has been stolen, then there's nothing that can be done. In just a period of 12 hours, that poor company had to close down. When I talk about IAM, remember that whatever structure you work with, when you start working with users, WAS would give you access for different people, different accesses for different people. IAM also allows to manage different functions, or what we sometimes call roles, with permits for different elements in our infrastructure, not necessarily people. It could be a machine with different permissions to implement different actions. We can also have users for active directories in the companies. And why is that interesting? because we can then use our corporate credentials to then access Amazon resources. So let me clarify that. I'll say that Amazon allows for control and access that's very, very detailed for different resources with multi-factor permits for different levels of privilege. We can manage access control for mobile applications as well. It also allows to integrate with a corporate Active Directory. So let's have a look now at a summary for the IAM dashboard. As a reminder, this is the Amazon dashboard. I think some of you will be familiar with this. Let's go to the IAM section. Can't you see that properly? Let's hope this works. Can you see it? No? I want you to see the dashboard up on the screen. Can you? Now, great. So this is the IAM dashboard with a link you need to access for that type of account. The main screen with a summary of security recommendations. I mostly want you to understand that when you start from scratch with an Amazon account, you have account settings. And this is a form where you can define your security policy for passwords. When you first start with an account, you have to define everything from scratch with the usual options for length, whether you're going to be capital letters or not. You can finely tune that to your needs. What about users? We can create nominal users because some users will access through the dashboard and other users through programs. If you use the dashboard, you will need a password. And if you want to use programs to access resources, then Amazon gives you an access key so that you can access that. So everything you can do through the dashboard is going to be using an API. So everything goes through the Amazon API. When you create a new user, it asks you what type of access you're going to have through the dashboard, and then you need a password, or, as I said, through programs. We can add tags, and then here I can create a new user. So I've created a new user with an access key. The user will have a password. I can't really do anything with it until I'm giving the permit, but to access resources through programs, then we should use both the access key and this credential here. And Amazon doesn't save the secret key. It does save the access key, but not the secret key. So if I don't save that tab, that's it. It's gone. So access information goes by email normally, but not the access key that would come through an encrypted zip file so that nobody can hold of it. Users can be grouped together. And what's the idea there? Well, to make administration easier. Because when users are granted permits, it's much better to do so as a group. It makes the system more simple, not to forget giving somebody the permission or not giving too high a level. So that's normally done through departments, so that the whole department is given it at the same time. So groups allow to add users, specify the level of permit. Well, I can't go into too much detail because my workshop is more about security recommendations, not about how to use the system. Here we can see the different roles. Now, those are permits that are given to elements who are not people. Well, they can also be given to people, but normally roles are given to a lambda or to a machine. And I also want you to see this, the credential report. This is an account I prepared just to show you here at Cybercamp. And why is this interesting, this example? Because as an admin of an Amazon account, you should have exhaustive control of what your users do. So you can generate a report. We've seen that earlier. This is a real example. I've changed some of the details logically for this Amazon account. Here we can see all the users for the account, when the user was registered, if they have a password, so they can access the dashboard or not, when they last used it, when they last used their password, if they've got the routing of password activated or not, if they have an access key, when they used it, all the necessary information for me to know if the user is making a good use, normal use of the account, or any users who are not using Amazon services at the end of the day. The security recommendation that tends to be applied for accounts is the following. You first need to have a secure password policy for your users, because when you first create the Amazon account, the policies don't just happen, because you need to set them up. Then credentials and passwords need to be renewed and changed regularly. Access keys should not be shared, and you might be surprised, but this is actually a reasonably common practice. What about recommendations for the root account? When we create our Amazon account, well, this one should only be used to give users permits. After that, that user should never be used again, just to avoid the problem that I mentioned earlier with that poor company that had to close down. If possible, we would buy a physical token for that user. We would keep the token in a safe. Well, I say a safe, or wherever is going to be safe, because the root user is the only one who has the possibility of erasing an account, or we could even set for alerts for a text message and to be sent every time a user accesses the account. That might be a good idea. The root user should never have access key allocated. Some more recommendations for users here. Those with privileges, well, we need to enable the multi-factor option. I forgot to show you earlier that when you, in your security credentials here, you have an option where you can add a second factor. That can be virtual in nature, or it could be a physical key. It's quite simple. Creating individual IAM users nominal users is the way to do it, not group users. Why? Because everything goes through the Amazon API, so all of that is recorded on a log. And if we had shared users, then and something goes wrong, we won't know who to blame. And we have to know who's done what and why. And later on, we'll see some examples. We need to have groups when we give permits. We should never give individual permits to a particular user. We need to also review the needs to pass keys. Not everybody should have programmatic access to the dashboard. About access keys, well, there's the danger that somebody might leave the access key in a machine. And that's terribly dangerous because the access key allows you to do whatever is being given permission to do. That needs to be avoided so that the basic list I showed you earlier can be complied with. Now, about the credentials and the report I showed you, this is important for auditing and monitoring account activities, for us to be able to find inactive users or keys so we can eliminate unnecessary users. For instance, users who have not had access for a year, well, they should go. How are permits allocated? This is a policy. Policies are pretty hellish to manage at the beginning. As soon as you get the hang of it, it's not too bad. A policy tells you what you can do or not with particular Amazon elements. The structure is a JSON file. You should also have the version on the file, because it's a version of the JSON file. And this is not for you to say what date that started. It is a set value that Amazon uses for validation purposes. Then we have the ID, and you can change that to whatever is good for you. And then we have that triple field: effect, action, and resource. Effect means if we allow or not whatever comes next. It just has two values: allow or deny. Then action, that means what we're going to be allowing or denying for different resources. Here you have many different options for Amazon resources. And then resource means what it is that the action is going to be touching. The conditions here are to limit more or less. For instance, if the IP making the call has to come from has to fall within a particular range, or if whoever is doing it needs to have multi-factor activated, or if the connection has to be secure. Because when policies are allocated to a particular user, we should realize that Amazon assesses policies in a particular way. Originally, we need to start and think that everything is denied. Users can't do anything when we first make them user. And then if there's explicit deny, then the action will be denied. If there's no explicit deny, then the system asks if there's an explicit allow. If there is one, then it would be allowed. If there isn't, then it would be deny by default, because deny is always far greater than allow in the system. If one machine says no, then the final result for all of the machines will be no as well. And now we're going to see an example of how these policies work.
As part of the policies, well, this is an account which is relatively new, and we have 468 policies. Why is that? because Amazon gives us a large amount of policies so that we can play around with them. So we filter those that have been managed by Amazon, those that we've managed ourselves, and only recently we've seen some policies that are kind of role-like policies. We have admin access, invoicing, database administrator. So this is more linked to roles than the permit itself. So when building a policy a few years ago, it was all JSON. So it was quite a mess, but now they've made our lives easier and you are allowed to do so visually. This example here, what we say is what service we want to enable. Let's say that we will have a policy for S3, and inside S3 we will allow for listing and reading, only reading on S3. So it's read only. And we could also indicate the kind of resources to which we want to have access, or grant access rather, and even conditions. So we check review, and we will not be allowed because we have not entered the bucket we want to have grant access to. In order to do this, we need to state the name of a bucket. So, let's say read only, which is that what's the date of the bucket, and then the kind of objects we want for that bucket, any object. These will produce. Let's add a description, is always advisable. I had already created this one, so again. And then filter, following our own policies, and these are the ones we've just created. This is the JSON we have. And this is the structure we've seen. Every action that can be run on S3, list, get, read only, everything that is read only, and this is the resource to which the permits have been granted. So the bucket that we've chosen and everything underlying it. And on top of it, it's an allow. We've seen that. So what about this policy? We can allocate it to users or groups. We've said it's more interesting to do so with groups. We set it for the read-only group. So we allocate that policy, we look for it, we look it up, and we just click add. And that's the policy allocated to the group. So everyone, so this is the read-only user Tobin, would have that permission granted. Complicated, I would say. The policies, well, they take training. Security recommendations, again, you might use, whenever possible, use the policies dictated by Amazon. There were over 600 policies already created with a wide range of options. Odds are there's one that will suit our purpose, but maybe that's not the case, that we might need something else that is not there. But if we can use one that is already there, even better. Also grant minimum privileges as low as possible. You always need to grant minimum privileges. And there's something very cool about it, which is the policy simulator. We will not see that here, but because I don't have the time, but this is an interface where we can get a user and say, what if this user did this with this policy here? Amazon will simulate it and will say available or not. Why do I say it's so cool? As I said before, Amazon uses APIs, so when you're sending calls within the interface of the web dashboard, the command you run is the last thing to be done. If you don't want to grant access to a user, for example, to erase a database, this is only done when they click delete. So if you go in and you choose delete and ask, are you sure you want to back up, you can click yes, yes, yes. But until you press delete or click delete, you don't know whether the policy you set is right one. What if you've got the wrong mistake and you've deleted the database because you haven't set the policy, which is quite a pain. So this will allow for that kind of simulation without ruining it. A few years ago, this was not available, and it's been quite welcome. Federate users, and we've said you can build or create and federate active directories from other companies. And that will allow for several things, such as having just one user and password for everything, making things easier. And you will narrow down security risks, because in the end you will only have one place where you will be managing all those passwords. You will only need to defend that, and you will have a global policy for the whole world without having to have a single policy for every password environment. But the fact that you don't need to type 14 passwords for 14 sites, well, that's a plus. I read that the IT, I saw that people wasted lots of time recovering passwords, so having a password hub, it's interesting. Let me show you a video, a short clip, not the way to set up the federation, because it's just a setup thing, but I want to show you the example of what it would mean. This is a federation. I'm going into this corporate site, my password and my user federated against Amazon. So the credential allow me to go into Amazon, and I don't need to have a specific user. So you build roles. So if you go into directory, you are allocated the role identified within Amazon for that. So now we move to IAM. Well, we've done rather with IAM. Now we move on to data protection. As part of Amazon or any environment, we want to protect our information from two different viewpoints: communication and storage. And there, so Amazon gives us a service which is Certificate Manager. Certificate Manager allows us to have certificates that we can use as part of our communications, and so we can create secure communications on the transport layer, for example with SSL. Those certificates, well, are free. So if you've ever had to buy them, they are expensive, but Amazon gives this for free for 13 months that we can renew months on end. These are RSA, also 48-bit, and also other protocols, what you can find in the market, but again, free of charge. Those certificates we will be able to use in front of the balancers. We will have them for content distribution on CloudFront when we create our own APIs, or even in more complex services such as Elastic services. Which means that in the past, you would get a server, get a certificate, and make sure that you would activate the HTTPS communication. Problem here is, Well, it's not that it is a problem, but it's an issue where the server itself has to be in charge of encryption tasks, and so you're adding complexity to it. And then Amazon or these kind of services have been designed for self-escalation, and so you need to have that identified, different server and everything. But Amazon will allow you to add a balancer in front of the machines and allocate the certificate to that given balancer. So every communication with the machine will be through the balancer. The balancer will be the one in charge of the encryption and communication tasks. And then with the balancer to the server, well, we can forget about that because that's internal communication. We can also add a certificate there if we wish to. But once we are inside the UPC, we might understand that we do not need the encrypted communication because the first threshold, that is the balancer, is passed. We've passed it. If we request a certificate, this is the second clip. We don't have any more clips. But this is a video where I clip because requesting a certificate takes some time. And I just wanted you to see it. If we go into Certificate Manager, we state the domain for which we want the certificate, and we need to own the domain. We cannot build or generate a certificate for CyberCamp or anything of the sort. It has to be ours, because the next step will be to verify that we own the domain. Here, for the example, I said, okay, email me to my user, because that's my domain. And so it's easy for me to verify. You will get an email as you see it here. So this is to be validated as well. And when you get the email, you click on the link, you get to this tab and you say, yeah, this is me, give me the certificate. And once you've got it all validated, so we refresh it, it's been issued. And with this certificate, we can use it throughout our infrastructure. Let me close this down, or else we keep going on. As for the security of the data that are resting, all the information we had stored in hard drives, S3, anywhere. We have Amazon KMS, or Key Management Service, for encryption keys that we produce in our infrastructure. So we see what roles they can manage, we can use them, you can use it, you can manage it, and you can decide. They rotate automatically, so you will generate a key that they are not that will rotate, and it's a transparent process for everyone. We can enable and disable them temporarily. You can audit. Well, it's not that you can audit, but we will be auditing when we get to that point. You can audit the way those keys are used. We will know who's used them and what for and everything else. And there's something important here, that is that we can bring to KMS what we had from our environment. So we have a series of servers and CPD, and we can upload it, and no problem there. KMS is integrated with or embedded with interesting services such as EBS, hard drives, see that in a minute, with S3, which is mass storage. So anything that is data storage, we can use KMS. We can use that with databases. That's where we keep all the information. And of course, as I said before, we'll send it to CloudTrail to use it for the auditing of what we've done. I will not play the demo of KMS because it's pretty simple, and since we are short on time, I had to summarize it. KMS recommendations for information encryption. We saw transit information and resting information. Security recommendation. Always make sure that you will encrypt the transit information on your system. And you need to make sure that you encrypt the resting information as well every time. In case it's not clear, do encrypt, do encrypt, do encrypt. Maybe some few years back, it might have been a problem, but with the computing power that we have today, having it all encrypted, it is not a delay, it's not a penalty, it only brings us something good, so use it. So let's see infrastructure services. UPCs. Next. This is just a virtual network, a private virtual network, where you can feed all the elements that we'll be using there. So these will allow us to control it all. IP ranges, we will have tables and everything. We will be able to lock several VPCs, sorry. As I said when we started, we have several of them. We can connect them to each other, and we need visibility. We can also have sub-networks which are public, and we can also have private sub-networks that communicate to the internet through those addresses. To give you an overview, this is our Amazon account, where we can build a VPC, but not just one, several of them. There's this circle, which is the point that indicates the network, the output network. We can connect them to each other with the VPC pairing. And we can have several subnets. We can decide whether we want them private or public, and each will have its own route or path table. Firewall networks, apart from producing subnets, we can also see availability areas. Just to summarize what this is, basically, Amazon has data centers scattered all over the world. That's what they call regions. And inside every region, there are several availability areas. For example, Ireland. Doesn't mean that there's just one data center in Ireland. They have 2, 3. And there you can decide where, in which availability area you want your stuff to be. Because they are separate or apart enough. So if there is a catastrophe and one is crashed, you can have it elsewhere. And you don't lose all the infrastructure down there. A clear example here is when we set up a VPC with high availability. Here we would have a VPC with a subnet segment inside, which is availability 1, and then another one is availability 2. So we will use only one, but if there's a catastrophe for this, it has to be a true disaster. But if the whole area is down, with a router, we can direct all requests to the second availability area, and that's where none of our clients will learn there's been a problem. If all others crash as well, or a whole region, that's something different. And we can even have contingency plans and keep things in different regions in order to be ready. That would be a zombie attack, or, well, quite weird. As part of the networks and subnets, we have the NAC else. It is a security layer that can be allocated to every subnet in there. So that's a rule list where we can indicate protocols, ports, and choose acceptance or denial rules. NAC else are allocated to subnets. That's more or less the same, but we'll use it for Amazon. So, at a given point, we can have subnet rules and also machine rules. So let's see what it all means. VPC. This one I built myself. Cybercam 18. For a development environment, which has an ID. We'll copy. There we see the allocated subnets. We can have the VPC filter, and if you see there's 4 subnets, 2 private subnets and 2 public subnets, each of which on different availability areas. AZ1 is different from AZ2. These are 2 different areas. Each of them has its own path table. Have it here. Hope you can see rules as well. The knuckles. We're allowing all of the traffic initially, so you have them here. Path route can be assigned or allocated to several subnets or just one. I would recommend having 1 per subnet, and even if they are similar, but then we can distinguish them based on what we need. We also have the internet gateway, that is the output for the internet. So I say it is interesting. These connections, these peering connections, so 2 VPCs see each other. We only say which source and which destination or input and output. And as long as the IP segments we've defined can see each other. So if both VPCs have the same IP ranges, there will be some colliding going on. So when building a VPC, you really need to have designed the ranges that you will choose. So if in the future you need to have them connected, you need to be able to do so, because it cannot be changed afterwards, after it's been created. Here you have the knuckles we've seen before, access to all security groups. Security groups, we'll see that in detail when we get to the machines. Something else, when you build a VPC, there is this option, which is flow logs. Flow logs is information going on inside your network. Well, if you create them because they are off initially, you can choose when you... Well, let me explain. What is this? A flow log, mainly what we were saying is, well, everything going on inside the network, I want to record it. I want to have a log where I see everything going on. In order to build it, I can decide whether I want to grab all requests accepted or denied, or maybe all of it. I can have it on the CloudWatch. This is one of the tools that Amazon offers to do lots of things. Very much fun. And whether we wanted a bucket to process it with other kinds of tools. As soon as we built it, we can see everything going on. Security recommendations regarding VPCs, but mainly don't use it by default. So use one of your own instead of the one predefined by Amazon. So with your own IP range and everything you need, you cannot delete it. So don't you waste your time trying to delete it, because you won't be able. Separate your business needs in different VPC environments. I said that as we started, you can think of an environment with lots of VPCs, other with different accounts. If you choose to have different VPCs, separate them, put them apart. I found clients that had one single VPC inside of which they would have development environments, production environments. That's madness. Total madness. Keep it all as separate as you can. Use only the ping when needed. If 2 VPCs don't need to see each other, don't let them see each other. Enable the flow logs, as I just said. It is so simple and not costly when it comes to money, and it helps for auditing and everything else. It uses a well-defined model in the network and decide whether it's private or public, if you want subnets for the database, anything you need. On private subnets, have everything that does not need to have access to the public. If it's not a web server, if you don't need anyone going into it, then move it to the private part. Use the knuckles to grant and deny access, generally speaking. When I say generally speaking, what I mean is if I use a knuckle where I state that all the machines inside the net segment have the port to deny it, doesn't matter whether on the security group I say yes, because the network policy trumps every other policy. Use the knuckle to restrict IP access and not the security groups. And remember, as I was saying, the knuckle rules have top priority over anything else. And don't use the security groups that you get by default. Delete the rules. Well, you cannot delete the groups, but you can delete the rules. And those that are by default grant access, and you might forget and allocate it, and you can cause quite a mess. Reference to other security groups instead of IPs. And in a minute, I'll show a security group example, and you see we will be allocating an IP, but you can also see a security group ID, which is great. But when you have to allow access for different machine groups, it's a mess if you have to go into every machine and say, this is granted access from 7 machines, and I state every IP. It's much more fun. So the machine that belongs to this group, you grant access to this other group. And so these are permits for the group, easier to manage. Just open the ports that are needed. If you don't need them, close them. And if possible, avoid the rules that grant public access to your resources. Naturally, if you have a web server, it has to reach and you have to have it. But if it's not strictly necessary, avoid that. Next, infrastructure services. C2, EC2. These are just instances, as they're called. These machines that we will be getting live are ours because Amazon cannot go in and do anything with them. If you go live with a machine, this is your access inside the machine and it's your responsibility. If it's not updated, if there are viruses, Amazon doesn't go in. It's up to you to an extent where if you lose your password, Amazon says throw it away and set another one up. We will have access and it will be SSH and with ARP, whether it's Linux or Windows, that's what's deciding that. And the maintenance of those machines is on us.
Máquinas hay cientos, ¿vale? Podemos ver máquinas.
And there are so many different machines, general use ones, optimized for CPU, all sorts. Some of them are tiny, for instance, a CPU with 0.5 giga memory, to situations with 12 terabytes of RAM memory. So you have to choose from that range what you need, get the price right. So I can tell you, going live with one of these 12 terabyte machines is quite amazing. Strongly recommended. And then we have the key pairs, an ensemble of both public and private keys. Key pairs are not given at the beginning by Amazon, so it's up to you. And what is a key in this case? Well, it's something like this, like we can see up on the screen, a very long piece of text. Then C2 has Amazon images. What is that? Well, a security copy for that machine. You can say, hey, I've got this machine here. I'm going to save a copy as if it were a backup, just in case I want to have another one go live if I scale up the system. Then we have the marketplace where AMIs can be purchased or up and running with different services. For instance, an AMI with a PHP, with Apache or whatever. Well, you do so. Or firewall tools. All the information stored is stored on EBS. What is that? Well, the disks from SSD to the usual old HD disks. The sizes go from 500 gigas to 12 terabytes, a whole great big range. When we use EBS disks, an instance needs a hard drive to work. And then you can have secondary disks so that when the machine goes live, you can decide to encrypt. So all that information will be encrypted. But the root disk for the machine to start cannot be encrypted when the instance is created. And yes, you heard me right. I know this is quite surprising. It cannot be done by default. So what would you need to do? It's not that complex. Look at that example. A machine with a root unit. So you would get that root volume and do a snapshot, a security copy. And then after that, we can make another copy of our first copy and encode it. So that's it. You've encoded it. You stop your machine. You remove the root unit that you have without encrypting. And then keep going with your new encrypted one, which is a bit of a pain in the neck. You do your AMI. And then after that, you can go live with the rest of the machines you use. Let me just show you an example of how that works. Here it is. On F2, we've got the list of instances. Here, I've got the Ubuntu machine is a very little one with just 1 giga of RAM, which works beautifully even with very small instances. So the information for that machine tells us the security groups that have been allocated. And the groups, the security groups, are here. Which ones are allocated for that machine? Well, we've got the rule that says that we allow for connection to port 22 from this IP. So this machine, we copy the IP, we try to access it, a machine, by the way, that works with Apache. So there's no rule that allows us to access through port 80. It's thinking, and then it doesn't let us do it. But if I get a rule and say, I want you to enable port 80 for this IP. You can say for a particular IP or for identifier of security groups. There can be a description. This is a new field, which is very useful because in the past you had to try and remember what you'd done and how. That description field is very useful. And this is these rules work in hot mode. Let's see if it lets me do it. Let me try again. The tab seems to have blocked. It won't do it. What is the mistake here? I must have made a mistake. I'm going to restart the machine and see if that works. I was using it this morning. I was doing some work this morning. We'll come back to that in a minute. But I was saying the permit works in hot mode, hot application. It should work immediately as soon as you apply it. It hasn't, but it should. Let me just try it again, otherwise I'll just give up and you'll just have to take my word for it. It won't do it. Maybe because we have a lot of different gadgets working here at the same time. Maybe it's not getting the IP properly. No idea. This is the AMI that was used. Well, we have more details, but I want to show you this. That's the name of the key that was used to make this machine go live. If I wanted to connect through SSH port 20, I should use this key. And where is that key? Well, I have it. The system has the public key that the machine needs, and the private key, who has it? Well, I do. So, every instance working has a volume, an EBS volume associated where all the information is on the hard drive. This is 8 gigas associated to that machine, you see? And then you have the snapshots, security copies, which is an important starting point if we want to encrypt that volume. For instance, this one here has not been encrypted, but if I say copy, you see, then I see the option for encrypting to be done. It asks me for a KMS key for me to use for this hard drive, and then I could work with it with information all encrypted. This is the manager for the life cycle, because in an infrastructure with machines and hard drives, you should have a good backup policy. What that means is that you can have your backup plan. You can specify which areas should be covered by your backup. And that's why tags, I said earlier, those descriptions are very useful. You see, this machine has gone live, and you can see there some tags. This is an Ubuntu machine, and I've specified it belongs to the development area that is connected with the security department. And thanks to that, I can identify resources that I've tagged correctly. In my job, I do tagging all the time. Tagging is basic because that's so helpful for invoicing, finding vulnerabilities, all sorts. For instance, in the development environment, I can say here to do backups of everything. I don't need to specify each machine one at a time. And then I can say, well, do the backup with this frequency, how many backups need to be saved. I can ask for it to copy the tags, that's recommended, and even add whatever tags we need. Now, there are other settings and configuration options, but they're not so applicable for what we're discussing now. So, all very interesting options. So, what are the security recommendations for what we've covered? You should be using encrypted volumes. At rest, you should always encrypt then your machines from HTTPS channels. If you can do 443, don't do 80 as a port. You should also review security groups that are associated to your machines. Why? Because that's the gateway for people to come in. Don't say, oh, I'm going to open port 22 from home, and then you forget you've done it. Don't. Make sure that security groups are well supervised. Implement a backup copy and AMI, whatever you need. Generate an AMI that's right for you, because very often people set it all up and forget about generating the AMI. Big mistake. those machines that are on the internet in public Wi-Fi networks, then you should always configure the WAF firewall with different applications that Amazon provides, and it's quite interesting. And just like I said earlier, for the main account that you need to create your first admin user, well, in this case, you should also have that as well to generate your users that you need, but make sure that your master key is always under control. You can't rotate the key, and you would otherwise make the process much harder if you needed that process. So keep it separate. Now, in the container services, we're just going to see the RDS services. Unfortunately, we have no time to look at the database with all the config options and settings, but I would like to tell you a little bit about security. The RDS database, here we're talking about a service that you can use and administrate from a higher level. The database engines are Aurora, Oracle, Microsoft SQL, SLB. So we can have a database and make sure that all information is encrypted from the very beginning. You start your database, then you get the check on. And I'm not saying that all the information on the tables will be encrypted. I'm just saying that the database will be part of an encrypted hard drive. And this is a little bit like we said for instances earlier. A database, when you create it with encrypted information, well, let's start and think that it's not encrypted. What should we do? We should first take a snapshot, copy it, encrypt it, erase the original database, and then we would have our new database with encrypted data. To connect with databases, well, we've seen what happens with data at rest, but you can also connect to the database with information in transit, and we want that to be secured as well. Unfortunately, we have no time to look at each and every line. I can give you a copy of my presentation later for you to see the details later. So the idea is that for us to connect to Aurora or SQL, what we should do is that before the 5.7 release, the connection mode was different. You need to bear that in mind. We also have a special parameter, which is forcing the SSL connection. You need to set that on 1. MariaDB works more or less the same as we saw earlier for the SQL one. Oracle works exactly the same as what we saw for... Sorry, the speaker corrected himself. In fact, here there's an option that allows to enable the SSL. The SQL server is a parameter. You need a parameter, which is 1. And as soon as you do that, then it works fine. So let's have a look at the databases here on my dashboard. I just want to show you the parameters that you need to comply with for security purpose. Let me just get an SQL and a MySQL one. In this case, I'm going to say the environment is development. You need to enter all sorts of parameters for the type of release, the instance. Look at that list of machines, 300 and almost 400 gigas of RAM memory. This is what we saw earlier for availability areas. You can set up a database for 2 availability areas just in case one fails, then the other one will work. If we say no here, then it says the cost says will be around $15 a month. But if we say yes for high availability, that means that I have access to 2 databases, and that means the price is twice as high. You can specify the hard disk and space, and anyway, there are lots of details there. We have no time for that. I'm not going to create one. Let me just fill this in just quickly like this, because what I really want to show you is the next screen. Here it asks you, what VPC do you want? Well, we've created one earlier. Good. The subnet type, if we want it to be public or not, because a database can be set up for it not to be accessible publicly. Only from my VPC I can access it. Here you allocate safe security groups, different parameters here. Oh dear, this machine is so small that it doesn't allow for encryption, which is what I wanted to show you. But take my word for it. Here you can decide if you want the database to be encrypted from the very beginning. Here, configuration for the backup plan, when it needs to happen, what type of monitoring you want for your database, because there's the basic level and the advanced level at different costs, logically. And here, the area for log export, which is quite new, and that means that you can have all the logs from a database. In the past, the logs were there, but because this service is now on Amazon, there's access to the logs now, which is quite nice. About maintenance, you need to say when the updates should be done, how to protect the database against accidental arrays, catastrophes. So you can see this is quite thorough to protect from different problems. Here we have the tab for snapshots, which is like the backup, which the snapshot is done by default once a day, and then you can do more when and if you need it. I think that's probably enough for databases, but please remember that the details there for the databases, it's a little bit like we saw earlier for instances. Sorry, I made a mistake here. I'm on the snapshot area now. That was the mistake. This is where you can see if it's been encrypted or not. And connectivity here gives us access to the security group that the database belongs to. You just click here, and it's like we saw earlier for instances. It says that the port is open for the IP you specify, for instance. So, what are my basic security recommendations for databases in this case? Well, you should always use databases with the hard drive encrypted at rest. You should always deactivate alternatives. Make sure the connection is always through encrypted channels. You need to review associated security groups. You should have your backup policy adapted to what you need, and unless you really need it, your databases should be private. If you need somebody to connect from outside, then they would need to be public access. But even so, you should have a security group that's very restricted at the level of the machine, for instance. You should also use the root user to create other users, and not to connect. And generally speaking, you should also have different users for different uses of your databases. And permits need to be given at the level of draft field, as specific as possible with permits. So finally, before we start seeing more specific services for security, I want to talk a little bit about S3 services. That means that Amazon has unlimited storage space for information. EBS are kept on S3, logs are saved on S3. All that storage of information takes place at the S3 level. So when we're talking about large volumes of information or databases with associated space, the S3 is there. You're being charged for it, even if you don't see it as a user. It's been designed to have almost 100% durability. So for those of you who don't know about S3, all it is a gigantic folder where you can just drop basically anything. And then information is copied at the different availability regions, although you can also tell it not to. Apart from storing information and backups, it's also used for logs and for security information that you get from your services. New processes that work with big data. And also, it's very useful to retrieve information in cases of emergency or contingency plans for corporate backups. Well, it's not on tape anymore. It can now be stored on S3 at a very reasonable price. Here in bold print, I say that buckets, which is where you keep your things in folders. So those buckets, those basic units are safe and secure by default. So you have a new bucket and you're the only one who can access it unless you specifically give somebody else access. When you give access to buckets, those permits can be done in 3 different ways. One, giving a policy to a user, applying a policy to a user and saying, hey, this guy can access this bucket to do these tasks. Then within the bucket, you can also allocate a policy and say, this bucket can be accessed by these people for these roles and in these conditions. So if you say, in this bucket, nobody is going to be able to access it. Even if you've given a user a permit, because denial is always there by default, then the user wouldn't be able to access it. This is a typical policy for a bucket, for instance. Whoever comes, if the request doesn't come through HTTPS, then don't allow them to gain access. Any connection attempt that doesn't go through an encrypted channel will then be denied. Another way to indicate a permit for buckets was, in fact, this third one was the first one that was ever given. You know, the access lists, that old idea, but applied now to buckets. That's what was done to start off with, but because policies are much better, really, and sophisticated, really, the third option, really, I recommend you not to use it. This is the same diagram we saw earlier as a reminder. The deny policies always beat the allow policies by definition. What about interesting properties that we might come up with when we play with buckets. We can enable the versions or that policy. Why is this interesting? Because if you find something's wrong and you think I need to go to a previous release, you have a drop-down menu with a list of different releases and versions for that particular object, and then you can decide which one you need. So here it says server. Well, really, what we can activate is the access to the bucket, meaning that every access will be recorded. And then we can also do the same thing, but at the level of objects. We can save logs every time somebody touches a bucket, or also somebody every time save the object every time somebody touches the bucket. With predetermined encryption, any file that goes into the bucket will automatically be encrypted. This is really interesting as well. We can also generate events. What is that? Something that will run when something else happens. For instance, every time somebody drops a file into the bucket, I want you to send me an email, or I want you to run a process, or I want a machine to go live and do whatever on that file that has been dropped here. It's great. You can then automate all sorts of tasks. I'm doing really badly for time. I didn't bring you an S3 demo because, to be honest, it's not that interesting. But I do want to at least very, very quickly show you. Oh, unless I've erased it, then I can't show you logically. Oh, here it is. A file in a bucket with versions activated. So this tab allows us to select the version that I want for that particular file, which is very useful because if you're working in an environment where you're overwriting all the time, then this is terribly useful. Very practical. So my security recommendations for S3 are the following. You need to have your own policies at the level of users or resources. Avoid ACLs. Then force the policy for communication to always work through HTTPS. It's ever so simple. Can be done very simply. You should also activate by default the encryption of all information in buckets. You should also check and see if your products need you to use the versions. Sometimes it will, sometimes it won't. You should also have your policy for reviews, because most of the information that's saved in buckets is there because it's important, right? So we should always have policies for those buckets always under control. And if you need to distribute objects in a bucket where you distribute static contents to files or whatever, you need to configure a CloudFront. What is that? A distribution platform with many different cached objects for different locations, so that when you want to download an object, a song, whatever, it will happen much more quickly. And why do you want a CloudFront? Well, because it improves the performance and because you can also associate a WAF. We will see more about that in a minute, and you will understand why.
And as I was saying so far, this has been the summary of processing or computing services on Amazon, for which we've seen security recommendations so that we can use them safely and securely. From here onwards, the last module will be security services offered by Amazon. First one is CloudTrail. CloudTrail Well, that's the feature of Amazon to keep under control every log produced by the API, which is the basis of Amazon. So these are calls to the API, and every call on the API will produce a log. CloudTrail is the one that records all those logs and then shows them to us and gives us access to what we have. So basically, it works like this. CloudTrail records logs and stores them based on what we want it to do. It will follow different measures or actions. And so it will give us some auditing skills or features so that we can see different conditions or rules. Let's see in a minute what it is like, CloudTrail. I say it can be on or off. When I say it's on, it means that on our dashboard we will see for Amazon the activity within the last 90 days. Even if we do nothing about it, if there is an event that I want to know what happened 3 days ago, the information, I have it with me. Problem is that it's only 90 days. Some people might think it's too long, but for some project might not even begin to cover it. So if we want much more, we need to build a trail. The trail, well, basically you give it a name and you can decide whether you want it just for the region you're in or for every region. Maybe you're interested in having several trails for every region. You also need to indicate what kind of events you want it to store. You can select if you want them all on the read-only or write-only. You can also say that it needs to store extra information for S3 services and Lambda. Lambda, we will not discuss it here, but it is the serverless computing service with Amazon, where you can run batches of code no more than 2 minutes long in a very simple way. And it is amazing, again, mind-blowing. It allows you to do so many things without servers. You can nest things in and out, and wonderful. So Lambda and S3, and you can choose it if you wish. You can choose the bucket for S3 where you want to keep the information, because in the end you will be saving lots of information. Amazon wants to pay for it, so you keep it in your bucket and you pay for the space used. When I say lots of information, it's truly lots of information. For S3, it's not that much. If you turn this on, the cost will not go up that much. It's not like that. S3 storage is very cheap and no problem there. So when you build a trail, you get access. I don't create it here because what happens is the same as here, but instead of 90, well, more days. Since we've got this one, I'll show it to you. Here you have a screen or a display where you can check everything that's happened. Everything that's happened, you see it here. Just a minute ago, it says here that from Ireland, that's where we are now, the root user, I told you not to use it, but for the demos, I didn't have the time to create an admin. So do as I tell and not as I show. So the root user here, from this IP here, and this is the gap of time, with authorized security group ingress. That's when I authorize port 80 for the machine, I would say. And if you want to see the detail, you don't need to remember, because you can see that right away. All that information, you have it in JSON. And with an API call, you can download it and then try to set up all these scenarios you might think of. Here it says there was a time where you actually authorized port 80 for this IP. I know it was you. I know it was a while ago. And this is all information that is very interesting from the point of view of an audit. Just to give you an example, yes, a few years ago, we were working, and all of a sudden, we were sending a script, but it seems that the bucket for the script was missing. Someone had deleted it. No problem, because it was a development bucket. But all of a sudden, there was one bucket that was missing. First, it is a security problem. Who's deleted my bucket? But maybe it's not that there is an intrusion. Maybe there is a process that is misfiring and you need to know what's going on. So you come here and, okay, you can filter and say, I just want to get the events that are, I don't know, where's the bucket? Everything having to do with bucket. All those items that were bucket related and last night. So you can get a list and say, okay. Just like this, we learned the problem was that a user had inadvertently deleted a bucket. So we removed the permit and that was it. So Cloud stores all this information here. But then all that information, you can move to other tools that will allow you for other kinds of more accurate searches. So I said that any of these events, if you come here, you can see it as JSON. So you can upload this to other kind of tools and you can search as you wish. On this specific dashboard, as you say, that's not possible. You need to go in deeper. But if you need something a bit more specific, you have all the chances to import it into a different platform where you can perform searches as documents. So move it on Elasticsearch and search for whatever you want.
Con respecto a las recomendaciones.
Security recommendations for CloudTrail. Turn it on. So it's a 90-day storage. Sometimes that might not be enough, and the cost of it is nothing. Nothing compared to what you are setting up on Amazon. Turn on the login for everything, reading and writing. Also S3 and Lambda, the site we saw for setup. So click it all. A bucket for all the files. Turn on the default encryption. You didn't see this, but if you go to Trail, oh, so here it is. This is advanced. And that gives you the chance to encrypt all the information. There you have it. So do encrypt that information as well. And then you will end up with a set of data that will be very useful for a large project where you need to keep tight control of security. CloudWatch next. CloudWatch. That's the site that stores different things. I find it is a mixture of so many things, but basically will allow us to monitor and manage all the information that we will get from all other sites. We can use CloudWatch to define alarms saying, if this happens, do this. We can check logs and metrics and everything. It is quite simple. On CloudWatch, we can send there or collect things from there. It will monitor it all, and based on what it finds, it will take different actions. Let's see this one here. CloudWatch. CloudWatch. Well, we could use 4 hours to explain it. A pretty powerful dashboard. Being a master in CloudWatch, it takes some time, but I assure you that when you know how to use it, you can do everything with it. You can have great control over your systems and automate so many things. You can create a log on the CloudWatch and throw there anyone you want. There's a Lambda feature. Here you have it. You can create events, do whatever you want. You can send it there. You can also set up alarms. An alarm? What it says is, if this condition is met, do this. So let's say that we will create an alarm to monitor our machine, the one that is being developed. And we say, well, that machine, so these are the scores that we can check, right? And so we would be interested in learning about the CPU rate. So check my CPU rate for this machine. And here we restarted it, and that's why we have a use peak. And so I want you, that is the machine, the program, to see the CPU use or rate. And there's this alarm where if the CPU use is greater or equal to 80%, let's say, for 5 data points, which is just a second, if I'm not mistaken, I think it's a minute. So if the use of CPU is over 80% for over 5 minutes, there's something going on. It's not that it's wrong, it might be good, it's not bad, it might be good. It might be that there is a wonderful visitor peak in our site and our e-commerce is selling so much, but we need to know. Maybe there's someone who's using a force brute attack, and we need a brute force attack on us. So we need to understand that the CPU is over 80. So 80% use for over X minutes will be an alarm. We can have a warning and say, if this happens, send an email to the manager, administration. And we can do things as nice as say, let's improve the self-escalation. So you have a machine, I'll guess that there's many people buying at your shop. So I get the machine and get it and get a load balance, and I will scale it. I will balance the requests and make sure that automatically your machine that was not enough, now it will be 2 machines that can endure that traffic. And you might say, okay, when this happens with this machine, which is on a subnet, which is a private subnet, and I know this problem should not happen there, what I want is that automatically you need to stop the machine or even delete it or reboot it. So simple as that, we can keep under control a parameter such as CPU rate or memory rate or drive writing rate. So many scores and parameters that we can keep under control. There are other events as well with rules, but I'll show that 10 minutes from now. So forget about it for a minute and you will understand it easier later on. This is rules. If this happens, do this. It's not about scores, but actions of any kind. As you see, there's a bit of everything, alarms and everything. So it's a dashboard that, if you ask me, it's a bit messy because there's lots of things mixed in here, but it's extremely powerful. Security recommendations for CloudWatch. So get familiar with it. It will sort out so many of your problems, but you need to use some time. It is not that easy. It's not super complicated, but there are so many options, and you need to use some time and keep familiar with it. You need to see what's important for your resources and choose the scores and the metrics. There's 180 of them. We do not need to monitor everything, but some will be interesting. Set up the alarms based on the score. Some of them, well, you just want them to have an email. For some others, you say, okay, turn it off because someone's trying to crash it. And also use events to send actions to solve the warnings, the alerts. This is another service which is very interesting, but I don't have much to say about it. Shield, which is just a defense against DOS attacks. And why do I say there's not much to say about Shield? Because it's very transparent for the user. Amazon says, don't you worry, I'll take care of it, and that's it. All right? So there are 2 types of setup for Shield. The standard one, that all accounts have by default, and then advanced. Standard will only check everything that has to do with network monitoring, but has not a layer 7, but the advanced one has. And then there's DOS attacks that get halted unless it's too advanced. If it's small, it'll be halted. If you have an infrastructure which is a larger company and you think the attacks on you will be significant, you need to go to the advanced version. So the advanced model is $3,000 a month plus what you spend after an attack. So for a small account, not interesting. You don't spend that much, not even on infrastructure. But for a larger company, it's so very interesting because first, there's security checkups, which you don't get with the standard one. But there's something wonderful. If you've actually got the advanced and there is an attack that has been successful, Amazon sends a guy to your office, an Amazon security expert sitting next to you, and won't leave your side until it's all solved. No one wants an attack, but you know they are so expensive that it's money well invested. Those $3,000 if you get the visit. So I will not run a demo for Shield because Shield's top is the 2 shots that I showed. I'm here. I'm on. It's by default. Don't you worry. I'm in charge. But there's nothing you can see. WAF next. Is an app firewall. It's a layer 7 grade, and it'll be in front of all the apps, all the servers on the internet, API, and everything else. And these will filter the requests based on the rules that we've defined. These rules can be different types, for defense against code injections, cross-site scripting. You can also have known attack rules from WordPress or others. So what happens? These are a drag. The firewall rules are complicated to develop, and setting up a WAF that has true filtering of what you might get in is quite complex. So we have managed rules, a set of rules that manufacturers give you right away. You download it and go live and everything. All the rules are already on. We have regular manufacturers in the business world such F5, Fortinet, and others. How does it work? Basically, if you come to WAF, I created it just before I came in because it takes some time to go live. And so it's done, and this is what it looks like. Again, you can download the rules. Some come at a cost, some others are free of charge. It will depend on what you have. The rule set that you trust the most, Amazon gives you the set of rules. They defend you from the 10 most ordinary attacks. So the OWASP top 10. So you can see which ones are created. Well, this is cloud from distribution, so none is found. But this is for Ireland. But this something that I've done with a cloud from pattern, which is great with Amazon. You can have infrastructure from a code, so you can have a JSON file or Java file, and you have this infrastructure described here. And then you say, go live, and all the services go live automatically. And you can have that on your infrastructure, version 1, 2, and you can go live with different environments. This is great because you can start thousands of resources. This is something that Amazon gives you. And I'll share it with you when I give you the presentation. Since I don't have an app, you can see no evidence of a potential attack or anything of the kind, but for the first tab, you would see if there's any activity. Second one, you see all the rules that we have here on this WAF. For the whitelist and blacklist, and also HTTP, flood attacks, and also massive scan, also reputations lists, SQL injection, cross-site scripting. Inside each of those, what does it do? SQL injection. All this is checked whether there is an attack on the URL string call or anything inside it. So many places where you make sure there is no injection that can have an impact on your server. You can also have login generation. WAF will get requests or queries. If they do not meet the rules, they will be cut out. But we want a log of everything that's been done, so we can also send it to an S3 bucket and manage it elsewhere. And when you create a WAF, down here, you can add it to so many things. You can have just one WAF for so many resources. Just here, what you say is, if you want it on a load balancer or on an API. Since I don't have a load balancer created, I can choose it. But if you have 14 in the pipeline, you can have a WAF for both. And this will be the one that will get the requests. And it is Amazon that will scale it. You don't need to see if it's coming from one machine or several machines. If the WAF needs to be escalated, it'll be done by Amazon. So very interesting as well. And so whenever there is a load balancer, add it. Oh, sorry about this. I forgot. WAF security recommendations. Do you need to deploy it? The cost, again, very low. Do you only pay for the rule set? Usually it's €4 a month, a WAF. No money, is it? Use it. Use it. Use the managed rules as starting point. Do not set it up. Download the rule set. Amazon gives you one free of charge. You can start with that. And then you can create the rules that you need, fine-tune to the needs of your project. And I allocate a WAF for every load balancer and their distributions. And we move on to Inspector, which I think is the penultimate, right? Inspector is another security tool. And it will help us see the vulnerabilities in our machines. If you've ever used Nessus or similar tools, well, this is Amazon's Nessus. So what was it? 5? So I set up a fraud agent and you can run analysis. It will classify evidence into high, low, and medium, and also for information as well. Since we're short on time, I will skip the packets that are the basis of it, but you can set up several scanning rules. Short of time. So let's expedite this and skip to the last part of it. Inspector. You need to say what machines you will be using it on and see what test packets you want to run and decide when you want to run it. What does it do? A findings list organized by priority. So you go in there and it says, well, this is a machine. I ran the test with Ubuntu. That's the name of the machine. And there is a high vulnerability on this machine, which is CVA 2018 well, what you see on the screen, and your curl setup is vulnerable as a version. So it says what's your problem there, and it explains how to solve it. So you need to update this packet here, and this packet here. And with that, you have these vulnerabilities solved. Interesting, because you can set it up for all your machines, and it runs every day, if you wish, or every second day, every third day, whatever you choose. Then you get a report you can download and forward it to a client, for example, or keep it in a history. So it's an agent on every machine that you want to keep under control, and Amazon communicates with those people, and that's what you get. Inspector's recommendations for inspector. So set it up for all your instances that are easy to use, so you keep all the vulnerabilities under control. Run a daily analysis, at least for those exposed to the internet. Set the frequency you need for every other instance. Build a plan to solve high vulnerabilities. Also build such an urgent plan for other vulnerabilities. And keep your instances as up to date as you can. Next, guard duty. Quite recent. And for those of us working on it, we find it great. A zip and we're done. Guard duty is Amazon's system monitoring everything going on Amazon. All the documents produced by us, by the API, by S3, all of it going through them, produced by Amazon, it will be stored and checked by guard duty, not just for your information. But it is based on an artificial intelligence platform comparing evidences you've got and those of other Amazon clients to find patterns. So the power is interesting. I'll fly through that, but I just need you to see that it is based on the trail and VPC and DNS logs.
We didn't talk about the DNS manager that Amazon does, but it generates logs as well. I'm pretty sure you're going to like this, and this is the cherry on the cake for us to finish the presentation. It's ever so simple, but have a look at this example, starting with guard duty, sending events to CloudWatch, and that will send a message to the user and to a Kinesis stream. I'll tell you what that is in a minute. That will save information in a bucket that will be sent as well to an Elasticsearch so that we can do really clever searches that we can have then on a Kavana dashboard. Sounds complex, but you can do it all in just 3 clicks, just with 3 clicks, and very interesting outcomes. Well, I get excited, you see, but I just love this. Guard duty is ever so simple. You just access it, and what do you have there? A button, just one button. So you enable it. You enable guard duty, and your intelligence system is checking everything for us. Right now we have no results, but let's have a look at the settings here with an option that says how often do you want to send information generated by guard duty. I tend to say 15 minutes there. You can also generate sample results because otherwise you might activate it and it might take 3 days for you to see anything much. Then it has an option to either disable it or for it not to work temporarily. Let's have a look at this. This is a false instance. This is what it says. And on port 3239, that's an ARP. Well, it's a Linux machine with this IP on this network. Well, you get all sorts of details of where the attack took place. And what was the result? Well, somebody from this IP at this port located in this particular city with the connection details that we have, and it connected, tried to connect to your machine, probably with a brute force attack. It's amazing, all the details it gives you. For this connection, the system considers is not legit. That tried to connect when it shouldn't then. What you can do then is for this to then go to CloudWatch, because Guard Duty has that option. And you then generate that rule from Guard Duty. You have this rule, you see. It says every time the Guard Duty service generates a finding event, every time it finds something, what will happen is, 1, an email will be sent by you through SNS to whoever you decide. And then that chunk of information, those details, will also go to a stream for delivery, or content delivery. Firehost is called, so that it can then be distributed wherever is required. What does Firehost do then? Just very, very quickly now. Let me show you this. Firehost gets the information. Well, I'm not going to tell you how to do the setting options for it to do other things, but this is where you say, I want the Guard Duty information to then go to Elasticsearch, which is a documentary database for very fast searches, right? So apart from having that endpoint for information, it also runs for a Kavaga endpoint. You see, this is it going live. You can define your dashboard then for you to view the information from Guard Duty. So these are just examples for you to get an idea of how Guard Duty works. Basically, it would tell you this instance with this identifier has had different attacks, Trojans, backdoor attacks, something to do with pen testing, cryptocurrency, brute force on ports, all sorts. So you can click on the different colors for details. What else have we got? The 10 most common findings, like your top 10, where connection attempts have been done to ports, which countries those attempts came from. You can see how severe the findings were. High, medium, or low severity. Or here you can filter and I just want to see those with high severity. Well, here you have the list with details. This particular event. You can also see that on JSON if you want to do anything with it. But anyhow, this object, you see, with all those details. Let me try and find it. This was a backdoor attack, an attempted attack. All sorts of details and information. This is a dashboard panel, which is really interesting to have everything under control in a very graphic design, so that you can then do other things more automatically. So, last but not least, my recommendations for Guard Duty. Well, basically, please activate it. It's priceless. Say how often you want to send events to CloudWatch. You should monitor all your resources securely. And that's it. That's all from me. I think I now need a little bit of fresh air. That's all, really. Unless you have any questions, which I'll be delighted to answer. Well, Guard Duty is offered for free for 1 month. And then after that, you'll be charged depending on the amount of information, because it generates data right? So depending on the number of data that it saves for you, you get charged more or less. Or well, you get charged twice for that, in fact, for storage and for analysis power. But you get it for free for the first month. Any more questions or comments? Nobody else? Thank you very much for your attention.